Okay, we're continuing to make progress on setting up to move towards hot fire testing with the Turborocket Mk VI unit. So here we see the test stand, and in the previous video you saw some of the flow testing we had done with the fuel circuit to measure the flow coefficients there. In this video we'll be talking about the crank air system and the installation of the Turborocket unit. So here we can see this is the Turborocket Mk VI unit. It's all on the stand. This may be where we get to, or we may have to remove it and give a few more tries to get it on and configured. You can see that we have the new RPM sensor, Hall effect sensor integrated with the measurement system, and this is the two nozzle Turborocket Mk VI unit with fixed beta angles of 3 degrees relative to the axis of rotation. This unit, like the previous one, has two magnets for balancing purposes, and that's accounted for in the RPM measurement software. So you can see the light flash every time the magnets pass by, 2 per rev, so that's working here. Over here is the crank air system, and the way this works is kind of like how you saw it before when we were running the isodynamic pressure testing. But in that case, we would open the ball valve, and then we would manually set this manual ball valve to set the RPM that we wanted. During run testing that we'll be using here, we'll actually be keeping the manual ball valve in a fixed position that gives us the RPM that we want to set for the crank air system. And then when the test begins, we'll open the motor-operated ball valve. So I just want to kind of show you that system here. We've set it at sort of a nominal position here on the ball valve. And so we're going to open the motorized valve using our switch box system here. This is on channel 8 here. So we'll be opening that, and you'll see the RPM start to come up as gas flows over the RPM. We don't have the Terry turbine type configurations. We're part of the testing that we're doing is seeing if we can get enough shear and just small body force pressures on these nuts and on the nozzles here to get the speeds that we want. And if we don't, we may machine in the Terry turbine type scalloping that you saw in the previous testing. But right now it doesn't seem like we're going to need that. So I'll show you a demonstration test of how this works. So we have pressure on the system. The ball valve is partially, the manual hand ball valve is manually cracked open a little bit, and the motorized ball valve is closed, but we're going to open that, and then you'll see the you'll hear the motorized valve start to open, but the sound will come up, and the auto dampening features on the noise channel here will allow us to not hear me speaking, but you'll see the system in operation. Okay, so we're going to open the manual. We're going to open the motorized ball valve by actuating it with our switch here. So here we go. 3, 2, 1. Okay, so that's how that system works. Hopefully you can hear me over the sound of the rotor spinning down, and that's how we'll do it in operation. When we're ready to do a test, we will have the manual ball valve in the position that we need it to be at, and then open the motorized ball valve to achieve the RPM that we want for the initialization and start conditions for the Turborocket Mk VI.